Now, please welcome Carla, Senior Technical Fellow at Boeing, for her talk on building a manufacturing digital ecosystem and foundations for Agentic AI. A 2026 Boeing Senior Technical Fellow, Carla builds the company's digital manufacturing backbones in materials, process, and physics engineering. Please give her a round of applause.
Awesome. Thank you. Is this on? All right. So I'm Carla Reynolds. As he said, I'm the Senior Technical Fellow in the Materials, Processes, and Physics function in Boeing. So I get the fun job of overseeing the digital side of MPMP. And so I'm going to talk a little bit today about the work that we've been doing for our manufacturing digital ecosystem. What I'll preface this with is we didn't start by trying to think about how we could make AI-enabled or agentic AI-enabled in our manufacturing system. We really started with a foundation of good data practices. I wanted data to be scalably accessible and usable by all of our engineers that are trying to solve problems on the factory floor and trying to make our products at high quality and high rate. And so this was really a path towards scalable, accessible data, but in the work that we've done, we found that when you build a good foundation, you can lay new technologies on top of that pretty easily. So I like starting with a picture of one of our production systems just to give some scale to what we're doing and to the products that we build and the production systems that we have. So this is 787 final assembly down in Charleston. Our products are huge and our production systems are even bigger. And so you can imagine the amount of complexity that takes to build these products. They are wildly difficult and there's a lot of stuff that goes on to make them at high quality. And so when you have that amount of complexity, you have a lot of different engineering roles that are also necessary to support the build of that product. And so when we start thinking about data-centric manufacturing and the ways that we want our engineers to be able to use data from the production floor to solve their problems, we also have to think about the scale of the number of problems that they're trying to solve and the context that they're trying to solve those problems in. So I like to show sort of a handful of the different engineers and the context of the problems that they try and solve. So you might be an industrial engineer on the floor that needs real part-time flow data to enable discrete event simulations and optimize and understand our rates and bottlenecks. You might be a materials and process engineer and need telemetry data to make sure that we're in compliance with our requirements and our build processes. Or a supply chain analyst who's trying to forecast the amount of material or parts that we need to order for our production system. He really needs to understand what we've actually executed on the production floor in order to do that estimation. Quality engineer, human factors engineers, there's so many others. And in this space, the thing that I like to talk about here is context really heavily, because a lot of these engineers need data from the same systems. They might even need the same data point, but that data point means something different to each of them. And so they need it in the context of the problem that they're trying to solve. And so historically, what it means to do data-centric manufacturing or make decisions in the manufacturing space with our data is that we had really small teams of people that would go out and do this sort of analytics gymnastics behind the scenes to figure out where all of this data sits in all of these different systems. They might produce a dashboard or an artifact that's useful to somebody at some point in time, but there's these really small teams that become bottlenecks to access and use of that data. It is not democratized. It's not easy for everybody to figure out how to go and find the data that they need and solve problems with it. And so the moment that this dashboard is no longer solving the exact problem that's hitting the floor today and we need change to it, there's only a small team of people that know how to make that change. And so you get into these positions where new changes or new capabilities take weeks and months to put in the backlog and then to prioritize for each production system. And so the people closest to the work lack direct control over the data to decision process. And that's sort of the paradigm that we've been in our production systems. And this is the thing that we've really wanted to solve for our manufacturing space. And those challenges exist for a number of reasons. I've named 4 of them. There are so many more. We've heard a lot about that today. Siloed data and systems. So in a lot of cases, data is generated for an initial use and nobody thinks beyond that initial use. And so it becomes siloed in a particular system for a particular use case. Context collapse. As you go from engineering into manufacturing, you lose the context of what you're trying to build. When I go from engineering to machine control data, my machine no longer knows that I'm building a fuselage or a wing skin or a bracket. It only knows to go from point A to point B and do a specific function. So there's a real lack of context, much less it doesn't know what work order it's working on or what production line it's in. There's a huge heterogeneity on the production floor. There are no standards for metrics, units, naming conventions, much less real ontologies that have been deployed. Everything is different from site to site. We're a global company. Our production lines are all over the place. No two sites look the same, much less two cells. Like two pieces of equipment from the same OEM can sit next to each other and use different metrics and units and naming conventions, which is wildly difficult. And with all of those differences and all of that heterogeneity, you get really, really limited resources. Subject matter experts become very narrowly scoped to specific cells, specific processes, specific places in our production systems. And so when people need their knowledge, it's really hard because there's a lot of people that start pulling on them. So this was the challenge that several years ago we started thinking about how we might solve this problem in our production systems. And what we realized is that this is very much not a Boeing problem. This is a manufacturing problem as a whole. And so we shouldn't create a new island of solutions internal to Boeing. But our first focus was on architecture. And these are wildly simplified architecture diagrams, and I know that. But one of the problems that we have in data access and use is the history of the architectures that we have for our production systems. So what I'm showing here is a point-to-point architecture. For every new digital capability you deploy into the production system, you connect that thing to the data producer or consumer that it needs information from. And then you do that again and again and again. And you build all of these silos of interconnectivity. And each one of those connections, while great for that initial use case, really obfuscates the value of that data to the next use case, to the next user, to the next person that wants that information to make decisions on the production floor. And so what happens is every new user that comes in has to figure out what things they need to connect to put their data in context to solve their problems. And you just really amplify this issue of connectivity and obfuscation of data. And so what we've been working towards is a change and moving towards something called a hub and spoke architecture. Again, incredibly simplified view of this. It takes a lot more than just inserting one new system into this architecture to fix everything. But what we've done in our production systems is this idea of data brokering or creating this hub and spoke kind of architecture. We're at the center of all of these data producers and consumers. We've inserted a brokering system, and it does just that. It brokers communications between our producers and our consumers of data. So if a machine is publishing its temperature data and there are 5 other systems that want that data, it publishes it once, and those 5 systems have one place to subscribe from to get that data. What it also enables us to do in a really powerful way is start to put data in context at point of need. So if your MES system and your machine and your ERP system are all talking into the same brokering system, then I know my machine data in the context of the work order that comes from my MES system or the scheduling that's coming from my ERP system. And when I have a new application that wants data in that context, it's easy for it to subscribe to it and use it at point of need, instead of having to do all of the analytics gymnastics behind the scenes to get it into a useful form so you can make decisions off of it. And so in this way, now all of our engineers have one place that they can go to observe data, to subscribe to data, to use data, and to publish back into this ecosystem. So every time they create new information that's of value, they can make that information known to others. And so we can build an ecosystem where we're building upon one another. So I wanted to put up our philosophy and how we're building this. I said that that view is very simplified, but I think these tenets are really important to the way that we've been approaching this problem internal to Boeing. One, we are really trying to eliminate point-to-point integrations. So drive out technical debt through the use of a hub and spoke architecture. We want to build to scale. We need to decouple data publishing from access, from consumption, so we can scale its usability across all of our production systems and our enterprise. Context is everything. This one is really important to me. All of those different engineers need data in different contexts to do their jobs and to really make decisions on the fly that impact our products. So we need to keep that context problem in scope. Discoverability and collaborative. We want this to be an environment where people work together. We want to empower teams to drive insight. We want to be future-proofed. We've created something that's incredibly modular. When one technology is no longer at the forefront, it's easy to take it out, replace it with a new technology, and so we can evolve as our tools evolve. We want it to be reusable by design, to have decentralized ownership, no more of these tiny teams that own access to data. We want everyone to be able to make decisions off of the data coming from our production floor, and we want it to be fast to deploy. And so, what happens when you do that is you get into this ecosystem where you've really disconnected your connectivity layer from your data access layer, from your contextualization layer, from your data storage, and then finally your application layer, which becomes really, really powerful. So now for every new application we deploy into the production system, we don't have to figure out all of those other layers every single time. We can lay it on top of this standard infrastructure that we've been building. And we've created this data-centric, event-driven approach where all of these different partners and applications can exchange data in a standards compliant way. So we've really, really leaned into data standards as well. And so what this means in this space of AI is that now with this digital manufacturing platform that we've been developing, AI just becomes one of those applications that you can lay on top. And so we don't have to figure out how to connect to access, contextualize, and store data to enable AI. We've already figured that out. And so we can lay the AI on top of that data platform and begin immediately doing interesting things with it. Right. And so this is just a really simple, silly prompt that says, I've been hearing great things about this digital manufacturing platform. Can you tell me what data is available today? And I'll say that it took us one day to go in, connect our internal AI tools to the platform that we have. It has MCP servers, it has APIs, all of the standard integration methodologies. And so it's very easy to start to integrate with. And what comes out is exactly what you would think from a large language model. It says, this is the data that I can see. These are the relationships in that data. This is what might be useful to you. And then you can start really tinkering around with what does it mean to create agentic workflows for our different engineers. And so this is an incredibly simple example of creating a research agent, gather, write, discover agent, but deploying that into a production system for a team that manages our SPAR automated fiber placement cell. And what we asked was, can you create a daily summary of this cell within our factory today, include an action item list, let me know what the high priority items are, and if there are any potential problems, and then draft an email to my team so we know where to prioritize our work today. This is an incredibly different way for us of interacting with the data from our production floor, from our machines, from our MES systems, and understanding what it is we actually should go out and focus on as a priority today, and not just relying on our history and our gut intuition there. So what comes out, again, exactly what you'd expect. This is the current state. These are the action items for today. Hey, also, you've had several e-stops on this machine. You might want to go figure that out. And so here's an email to the team to help prioritize their work for today. So both of these were very text-based. One of the things that I showed very early on was that picture of a dashboard. That's the way a lot of folks like to understand the state of the production system. These tools can really easily do that. And so we have historical data, we have real-time, live, event-based data, and we can ask the same sorts of things. Can you go and look at this particular trim and drill cell and understand the shape of that data, and then build me a dashboard that updates in real time to show me how spindle vibration is changing? And what comes out in real time is that dashboard for that user. And it's all against data that we have within our platform. We have governed, we have modeled, we have made sure is correct and coming from those pieces of machines so it's trustworthy. So using this manufacturing digital ecosystem, we're moving towards a paradigm where employees can access trusted data at the point of need, enabling faster, more informed decisions on the production floor. Teams can discover and use and build digital capabilities without putting a ticket into the backlog of a tiny team. They can actually access the data in real time when they're trying to solve problems on the production floor. And we can start thinking about what agentic workflows look like and how do we help our employees move from manually finding data to really orchestrating action. And so I'll put back up all of these different engineering functions and what they're trying to do as I finish out what I'm talking about, just to start thinking about we could have agents that were aligned with each one of these engineers. Maybe I have an industrial engineering agent for my 737 line in Renton. And so it's very scoped to the data that comes from that particular line, to the tools that that engineer uses, and to the ways that they operate within that particular production system. And so now they have a co-pilot that they can work with. So instead of spending their days trying to scrape together data, what they do is spend their days optimizing our production line. So we're really trying to think about how we change the role of the engineer and how we empower them to use data and really think about being able to do their engineering job instead of just being the person that goes out and tries to find data. And so really, the last thing I wanted to touch on is what it's taken to get here. So we've heard a lot about this, I think, all through the day, but this is not just an engineering effort. This has been an incredibly collaborative effort with IT. So we have had employees and digital teams co-create this platform and then the AI layers on top. And there are multiple different functions that are collaborating in this space. We're really trying to move data from ownership to stewardship. So instead of having this really small domain that you have access to and that you own, you become a steward of shared data that enables others to also solve their own problems. Standards as a common language. So building on data standards is incredibly important. So we understand the information and the relationships between it. And then this idea of flow over control. So we need access to seamless, trusted data so we can make decisions faster and focus on exceptions instead of trying to find that data. Okay, I've left myself a few minutes for questions, so I'll open it up.
Hey, thank you so much. This was really interesting, and I appreciated your focus on, hey, we didn't just do this because we like AI for empowering action. Something struck me though, and I'd love to have your take on it, was that because you didn't do this for AI, right? There was a lot of work that you actually had to do to make data useful, right? How do I think about how much of the level of effort and the return was because of the AI platform, but on top of it versus all of the work you did, streamlining and context and standardization before?
I think a huge amount of the value comes from all of the work in the standardization before AI. So AI opens up a number of use cases that we can use that data for. There are plenty of others that aren't related to AI or machine learning at all. And so we can use this data for all of those use cases, as well as anything that comes from sort of the AI machine learning space as well. And so I think the real value is in the data access and the relationships and the context that you're able to access that data in. And then AI becomes kind of a cherry on top currently. Yeah.
Thank you for sharing the beautiful presentation. I saw that there's a data brokering system in between now and the hub and spoke model. And also there's an HMI that also reads from that versus HMI reading from the PLC. So how's that experience, HMI reading from the brokering system and reading from the PLC?
So we have HMIs that interact directly with the PLC as well. So you don't have to get rid of that integration layer. But it's just saying you could connect directly to a PLC with the brokering system, or you could go through the HMI and also to the PLC.
And which brokering system would you recommend?
It really depends. That was very much a collaboration with our IT department, who gets to sort of decide on the financial aspects and what makes sense in our enterprise. So I think that's an enterprise question on which ones to use.
Sure. So I have a question regarding from the technical side for the architecture. Did you essentially that building a knowledge database yourself versus you do one of, let's say, the IBM or Amazon solution off the shelf? So we watch that. And then second, did you end up or is it more of building connectors that get to develop the aggregator? Like I just love to understand perspective.
Yeah, so everything in our digital manufacturing platform is a set of commercial off-the-shelf solutions that we have architected together to work within our enterprise. I would say that the platform itself, like we have a very strong boundary between data access and data storage. Data storage immediately sort of bakes in context, and so not every use case needs the same data storage. And so we have standard patterns for how you would interact with our lakehouse versus a time series historian versus, any other data storage platform. And so we have a suite of data storage platforms that are useful depending on the use case. And the platform is very much about making that data accessible in a standard way. And that has been done through primarily commercial off the shelf. Not everything can be, every enterprise is different. And so there's really specific things that we've built internally.
Last one. Okay.
How do you think validate the accuracy of? Like, if it is fast, or you can check it, but if it is predictive, if there's something you can give different answer because it's a problem.
Absolutely. So we're very early in using these tools. And so we're thinking about how do we do our validation? How do we have beta testing groups? There's going to be a whole culture shift around how we use these tools. And so a lot of that gets tied up. With these specific use cases, we had the person that runs that machine every single day looking at the output of what was coming from the large language model and saying, yeah, that makes sense, or no, that absolutely is silly. So it was really working with the subject matter experts there to validate the responses.
All right. Thank you, Carla, for sharing your insights. Thank you so much.